So, welcome everybody. This talk for today is by Satya and Mali. They have looked at the security, or maybe you could say insecurity, of home automation systems, in this case the HomeMatic. And I won't waste your time, so please give them a big round of applause, Satya and Mali.
Yes, hello. My name is Satya.
And I'm Mali.
And in the next 45 minutes, we are going to tell and show you how to sniff HomeMatic device traffic, how to emulate HomeMatic devices, and how to attack a HomeMatic system. This talk only focuses on the wireless traffic, so we are not talking about the wired components at all. And we are also not covering the numerous security issues of the LAN interface.
So, who of you does already use a home automation system?
Okay, and who of you does already use HomeMatic? Okay, a few. And who plans to install a home automation system in the future? Okay. This is the outline of our talk. First, we are talking a little bit about HomeMatic in general. Then we have to bore you with a little theory about the wireless packets of HomeMatic. And then we will demonstrate you live 3 possible different attacks. These 3 attacks cover pretty much everything, meaning after these attacks, you can, as an attacker, control pretty much all the HomeMatic devices, except when you're not using the default AES key when you changed it. Okay, HomeMatic in general. Our original motivation was we wanted to control valve drives directly. We were not satisfied with the built-in temperature control algorithms of the thermal control devices. And soon found out that it is not possible to control valve drives directly.
Yeah. Initially, we just wanted to write a new firmware for the valve drive device.
But that soon exacerbated into developing our own interface software to control HomeMatic devices, which we later named HomeGear.
So let's show us an example configuration. Maybe you want to start with some kind of starter kit. Maybe you want to unlock your door and switch on the light with a remote control. And if you're satisfied, maybe you want to add further components to the system. And therefore, you may want to have a control center. This may consist of a LAN configuration adapter in combination with a server running a Bitcoin service software and home automation administration software. Or you may use a standalone control center unit with a firmware doing as well the job of the Bitcoin service as further functions. Or you may use Raspberry Pi with a wireless adapter extension running HomeGear software. Then you can add devices like a smoke detector team or thermal controls to regulate your room temperature. Yes, in the very beginning, we started by opening a valve drive device. And inside, we found an Atmel microcontroller, a wireless transceiver module hidden in the back, and of course a motor and a gear. This device is provided in a very tamper-friendly version, providing the communication interface between the microcontroller and the transceiver module as a pin header. So we sniffed the traffic on this communication interface with a logic analyzer
and soon understood how the device works, and we could soon emulate this valve drive. Actually, on this valve drive, as you can see here, probably, maybe, is already running our own firmware, which we later did not develop anymore because it was not necessary. Okay, the wireless packets. The protocol used by the HomeMatic devices is called BitCos, which stands for Bidirectional Communication Standard, and works on a frequency of 868 megahertz, as a lot of wireless home automation system. And all the BitCos packets look like this. First, you see the packet length, which does not include itself. So the length counts only the bytes after the length. Then the first byte is a message counter, which increments by 1 with each message exchange or packet exchange. Byte 1 is the control byte, which, for example, encodes the information here at bit 5 that the communication is bidirectional. This bit, for example, means that there is a response expected to this packet. Byte 2 is the type of the message. Byte 3 to 5 the sender address, 6 to 8 the destination address, and after that the payload. There is one special destination address, 0, 3 bytes 0, which is the broadcast address.
Since most of the HomeMatic devices are battery powered, you will need some kind of power saving strategy. The first power saving strategy is called wake on radio, and is it works the following. The device wakes up to receive ready mode for 2.4 milliseconds, and after that it falls asleep for 350 milliseconds repeatedly. So it can react on packages almost immediately. The second type of power saving strategy is the wake me up mode. In this mode, the device sends a wake me up packet, then is in receive ready mode for 250 milliseconds, and then falls asleep for a variable but deterministic amount of time. This mode is used by some devices for which do not have to be reachable all the time when they want to exchange information with the central. They send a wake me up packet in broadcast mode, and the central can react and initiate data transfer. The third power saving strategy is almost the same as the mode above, but without a wake me up packet. This mode is used by a thermal control device and valve drive device. One slide back, please. The receive ready mode draws about 14 milliamperes of current, so that the battery would be empty in about 1 week. So if you use a wake on radio mode, the average current draw is reduced to about 100 microamps. And the other modes reduce the current draw to about 20 microamps, plus additionally the power, the current draw of the motor and the microcontroller, so that the batteries can last 1 year or even longer.
Okay. One important thing about the Bitcoin protocol is that the communication is completely unencrypted. But for some devices, like for example the KeyMatic, which locks and unlocks your door, of course you need some kind of authentication so that not anybody can unlock your door to your apartment or house. For this authentication, an AES challenge response handshake is used, meaning, for example, the central sends the command open door to the KeyMatic. This is the command. Then the KeyMatic generates a random challenge, sends this challenge back to the central. The central encrypts this challenge with the AES key known by both devices, meaning encrypts this challenge with the known shared secret, and sends this encrypted message back to the KeyMatic. The KeyMatic decrypts the payload and then knows, okay, the central is my central and I'm allowed to unlock the door. In the past, there were numerous problems with the AES handshake when you changed the default AES key. So still, some people say that you should not change the default AES key and use the default one to avoid problems. And one other disadvantage of the AES handshake is it has a very high latency. So for example, you can't really use it if you want to switch floor lights, for example. Yeah.
Yes. Before showing our first attack, I'd like to mention the most simple attack. The most simple attack is a burglar who wears a jammer device which jams the air traffic. That means it sends a carrier louder than the motion sensor so that the alarm system cannot hear the motion detected packet from the motion detector. So now let's start our first attack.
What are the requirements for the attack? It's actually not a lot. We are using a Raspberry Pi. Then we need some kind of wireless transceiver module for the Raspberry Pi in order to being able to send and receive bitcoin packets. You could use the so-called CUL, which you can buy at buzzware.de. But we are using a self-made device we named CRC, which you can see. Let me switch to the
either there or on our next slide.
Yeah, right. We have a picture of it. There's the webcam. There it is. This is the CRC on the Raspberry Pi. And third, we need some kind of software to interpret the signals of the wireless transceiver module. And of course, we are using HomeGear. Yeah, that's, again, the CRC. Here it's still named Cox.
Yes, our first attack is only is not much more than copy pasting a motion detector packet. For this, we need two informations. The first information is the address of the motion sensor used, and the second information is sorry, we only need the address of the motion detector.
No, and the address of the switch.
And the address of the switch, of course. Oh, I'm sorry. Now, for that, we need to sniff one packet containing both information, and then more or less copy-pasting this packet and sending it to the switch, and the light goes on without the motion detector detecting any motion.
The important question now is, when we sniff packets, of course there are a lot of packets in the ether, especially when it's a larger automation system or when there are a lot of devices. So we need a way to detect motion detector packets. So how does a motion detector packet look like? The easiest way to get this information is to look at the device's XML files, which you can find in the file system of the CCU, or which is also provided with the Bitcoin service software, which you can download from the HomeMatic website. And then in this XML file, there is a section called frames, which contains most of the packets known by this device. And in this frames section, you can find this frame, which has a message type of 41.
Hexadecimal?
Which you can see here, hexadecimal, yeah. And a payload size of 4 bytes.
Yeah, which is encoded in byte 2 of the packet.
Yeah. And has a payload size of 4 bytes, as you can see here. And with the last nibble being 0, this packet really is specific for motion detectors. So this is the packet we are looking for and we are sniffing for. After this packet, I'm just telling you in advance because you will see it in a few seconds. This is the packet from the motion detector to the switch, and the switch will respond with an acknowledged packet. Okay, let's do the attack.
Ja.
Warte noch kurz mit der Batterie.
There's some short information. This is the system of the victim, and this is the hardware of the attacker.
Okay. Here we are logged in 2 times over SSH into our Raspberry Pi. And the first question is, how do we sniff packets? Sniffing actually is pretty easy because all the packets are logged into the HomeGear log file, so we just use tail. It's a little hard to read from here.
Usually we do not log in as root.
And here you can see all the bitcost packets received by HomeGear or by our wireless transceiver module. Now, Mali inserts the battery into our victim's motion detector. We just removed it because otherwise the light would switch on and off all the time. And now if we wait a little bit, hopefully.
Mm-hmm.
I think it's crashed.
No.
Yes, it is. Die Lampe leuchtet dauerhaft. It's crashed. As you can see, it works perfectly. This is not part of the attack, by the way. We just want to switch on the light. Okay. Maybe we shouldn't have removed the batteries. Yeah, it detects when the batteries are inserted. Okay, now we know that's the motion detector. Okay, we can't show you what we wanted to show you, but we can use we can generate our own packet. We can construct our own packet.
We'll use the backup of our sniffing before.
Yeah. Okay, I'm sorry. Normally
we can sniff the two addresses.
Yeah, normally we wanted to sniff the motion detector packet and copy-paste it to the right side. But as that is not possible now, let's just connect to our HomeGear daemon. Now we are connected, or yeah, now we are within the command line interface of HomeGear. By default, HomeGear knows two virtual devices. The second one we don't need now. That's the virtual central. And the first one is a device we call spy device, which is actually the device which logs all these packets to the log file. And we need the first one.
Yep, now it works.
It's working. Perfect.
Needed some time for booting.
Okay.
Okay, let's show it once again. We have to wait some seconds till the light turn off again.
You can use, no, you have to wait.
Yeah.
But you can see already, here is the packet we just talked about with the message type 41.
Once again?
That is the sender address. You can see the sender address and the destination address being the address of the switch.
Once again?
Yeah, once again.
Okay, once again?
Okay, there it is again. And there is the packet after that. Remove the battery.
Okay.
The packet after that is the acknowledged packet from the switch. Okay.
Okay.
Now we are really.
Now we can't cheat anymore.
No, there are no batteries anymore in the motion detector. Now, when we type help, you can see the spy device supports a command called send, with which we can send arbitrary bitcost package, and we are using this command and just copy the packet from the right side to the left. I press enter, and nothing happens. We did something wrong, I think.
Try it again.
Try it again. Yeah, we will. We will. When you remember the slide, maybe you saw that part of the payload is a counter at byte 10 here. And when you sniff more packets, and as we sniffed more than one packet, you can see here, for me it's hard to see right now from this angle, but if you look through all these packets, you will see that the counter increments by 1 with each motion event. So maybe let's just try to do the same and increment the counter by 1. And ta-da! That was the first attack. You see, it's quite simple to emulate HomeMatic devices. And now the second attack.
Yeah. Okay, how to annoy your neighbor. Okay. One way to annoy your neighbor. You have a thermal control device, and mounted on the wall of your room, and valve drive device mounted to the valve of your radiator. These two devices are paired into each other, and each one of them is paired into a central. So our next attack is not that simple, but still we can manage to change the set point temperature to always on, so that the valve drive position is fully opened and
You can imagine.
We can have some fun, or maybe a burglar can use it too. For social hacking to make the victim open the window. Okay, and that's for explaining how the attack moves. Let's.
Maybe you remember this slide. We have a problem now because we can't just send the new setpoint temperature to the thermal control device. Why is that? In our first example, the switch we used to turn on and off the light was always receiving. It was always in receive ready mode. The thermal control now is a device of this kind, meaning it sends wake me up packets every few minutes and then goes to sleep again. That means if we would use the command send we used in the last attack, we would need to send within this window of 250 milliseconds. That's kind of hard to do. Manually. So we need a different kind of approach.
Okay, the first step is we need two informations. The first information is the address of the thermal control device, and the second information we need is the address of the victim's central. And in the attack, we have to change HomeGear's central address to the victim's central address, because otherwise the victim's thermal control device, which is paired to the victim's central, would not accept packets from our HomeGear device because it has the wrong address. Then we have to manually add the victim's thermal control to HomeGear in order to make HomeGear manage the timing of the attack, because manually you can hardly hit the 250 milliseconds window. The third step is to change the setpoint temperature. And the fourth step is to switch the thermal control mode into central mode, because if the thermal control device is in a non-central mode, it would not use this temperature set before by us for the actual valve drive device. The easiest way to do both steps is using RPC functions, set value and put param set. Slide before, sorry.
Yeah, now our first step is, or we need to identify the address of a thermal control. And to do that, we need a packet that is specific for thermal controls again. And yeah, the XML files are our friend. So we just look into the XML file of the thermal control device and there find a packet with a message type of 58, which is specific for thermal controls. So we just need to sniff for a packet of this message type, which we are doing now. While we talked, HomeGear, of course, was recording all the packets received. And as you can see here, there is a packet with message type 58. So this most definitely is a thermal control device. And this is the address of our thermal control, 1D E790. The second address here, the destination address, is the address of the valve drive. So this is the packet sent from the thermal control to the valve drive. And yeah, then the second information we need is the address of the central. To identify the central address, you need just to look for different kinds of status packets sent to the central. We are not yeah, I'm not going to show you or yeah, what the status packets are, but there should be one here in this list.
But before doing the attack, please switch to the webcam to prove the valve drive is almost close.
Here, for example, that's 1C6940. Yeah, that's the central address. That's a status packet sent to the central. Okay. Yeah.
Might you switch?
1 second. There.
Okay. As you can see, the valve is opened by only 17%.
Maybe show the thermal control too.
Thermal control has the actual temperature of 21.8 degrees. Doesn't matter. And what's okay? And you have to release the button and a set point temperature of 19.5 degrees.
And the mode is manual. Yeah, it's okay. Okay. Now, let's do the actual attack. First, you remember the second device was the central. This is the central address, and this address is wrong. So we need to change it. In order to do that, we remove the central. And create a new one. With the correct address, with our victim's central address, 1C6940. Then we need a completely arbitrary serial number. Can really be anything. We use the serial number vcentral01. And the device type, as you can see here, the device type of the central device is FF, 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 FD. And now we have a new central. There it is. Now we select the central. And here you can see there is a command called peers add to manually add peers without pairing them to the central. And we are doing exactly that. Peers add. Now we need the device type first. The device type you can find in the XML file. The device type of the thermal control is 39. Then we need the address, which was 1D E790. Then we need again an arbitrary serial number. We call it virtual thermal control 1. And the firmware version, the most current firmware version is 2.1. This information you can also get out of the XML file or by just inserting a battery in a thermal control, then it will display the firmware version. And now HomeGear knows the thermal control of our victim. We are logging out. We don't need the command line interface anymore. And now we need to tell HomeGear to set the new set point temperature for us. To do that, as Mali already told you, we are using RPC function. One way to do that is to use a simple PHP script. I called it setpoint.php. Oops, sorry. And this script actually is pretty simple. The class I'm using pretty much only uses the XML RPC functions provided by PHP itself, so it's really nothing special, and you can download it from the HomeGear website. And as you can see, we are sending two RPC functions. The first one is setValue to the thermal control we just created in HomeGear. You remember we named it VTC1. The variable name is setPoint. Again, this information is out of the XML file. And we set setPoint to 100. 100 is a special value, meaning always on. And the second RPC function we are using is put_param_set. Put_param_set is used to set configuration parameters. So we are using put_param_set to change the mode of the thermal control to central mode in case it is not in central mode. And again, this information is out of the XML file. We change the variable mode temperature regulator to the value 2, and 2 is the central mode. Okay. Now, we are just executing our script. On the right side, on the left side in the log, you can see that HomeGear received both RPC packets. Now we need to wait a little bit because it takes 2 to 3 minutes for the thermal control to send a wake me up packet, and then HomeGear starts sending. In the meantime, I am showing you what you will see. There will be a little more packets than you saw in the last example. This is the wake me up packet, and in response to the wake me up packet, HomeGear will send a wake up packet. The thermal control will send an acknowledge, and then HomeGear will send the new set point temperature in this packet, encoded in the last payload byte, C8 being 100.0 or the special value always on. And an acknowledge again.
Encoded as 200 in decimal, so that you can encode values between 0 and 100 in 0.5% steps.
Yeah. Okay. And the second RPC function, put_param_set, causes HomeGear to do this directly after setting the set point temperature. As the central mode is a configuration parameter, it is handled as setting configuration parameters, which is done always in the same way. Setting configuration parameter starts with a start configuration packet and ends with an end configuration packet. And in between is the packet to actually set the configuration parameter, which is encoded here in the last byte. A lot of information for 1 byte, but yeah. And in between are acknowledged packets so that HomeGear knows that the packets were really received. Okay, let's switch back and see if something happened. Yep.
Actually, it did.
It did, yeah. Where's the wake me up packet? Okay.
Wake me up packet.
1 sec. Okay, in this case, we responded to the packet sent to the of message type 5.8, so not actually to the broadcast packet. This is working too. This is the packet sent from the thermal control to the valve drive, and after this packet, here you can see the set point temperature being set, the configuration start packet, the setting of the mode to central mode, and the configuration end packet. Okay, now I'm switching to the webcam again. And
as we can see, the valve drive opens the valve step by step, 88%.
Okay,
98%.
That's the maximum.
Almost fully opened.
And here
and the
you can
set
see
point temperature.
The set point temperature is on. And here you can see that the thermal control is in central mode. That was the second attack. Okay, last one. Time is short.
So.
Okay.
Yeah. Third attack, we're going to show you how to open a victim's door if the victim has not changed the default AES key.
That's probably the case for a lot of people, and if the reason is being lazy, but I think a lot of systems still use the default AES key.
We might do some war driving to see how many people changed the AES key. So again, we need two informations. The first information is the address of the KeyMatic device. And the second information we need to know is the KeyMatic device. And the second information is the address of the victim's central. So we have to sniff both informations. And as soon as we got these two informations, we can send the command open door together with the AES handshake with the default key. For that sniffing, we might use the Raspberry Pi and the CRC. But for sending the AES handshake, we need LAN configuration adapter together with a bitcoin service running on our computer.
Okay. Yeah, sadly, HomeGear doesn't know the default AES key, so we can't generate the AES handshake. Okay, let's start by sniffing. You already know the procedure. And yeah, Mali, you're the victim. Close the door.
Okay.
Oh yeah, the webcam.
Can we? Okay. I have the door still open. Now I close it.
Okay, and there you saw, here are the packets.
Okay, now I put away the key.
Okay, this is the packet we received. So the sender address is the address of the remote, and the second address is the address of our KeyMatic. 23DD6F. So now, and from the previous attacks, you already know, or from the previous attack, you already know the central's address. So now let's do the attack. One sec. What we need to do is, first, we need to change the address of the LAN configuration adapter to the address of the victim central. Otherwise, again, the KeyMatic wouldn't accept our packets. Then we need to manually add the victim's KeyMatic to the bitcoin service. And after that, we can just use the RPC function setValue again to set the state of the KeyMatic. In this case, the state would be open or close the door. No, lock or unlock the door. Oops. Okay, let's do it. First,
I don't touch the remote control.
This is the configuration folder of the bitcoin service, C program data bitcoin service. And you see there are no devices, that's why this folder is empty. And I am copying a template file into this folder. And there are no secrets. I'm going to show you what is in this template file. Actually, we need to modify it too. And you see, this template file looks pretty empty. There are no, yeah. And in this template file, we just need to enter two information. First, the address of the KeyMatic, 23DD6F. That's what we just sniffed. And we need 23DD6F. And we need to enter the serial number of our bitcos interface, of our bitcos, of our LAN configuration adapter. Of course, we know that one. And the address is 314785. 123.14785. Okay, now let's save it. Close it. Now, now we start the Bitcoin service on our attacker system. It's running, and we are again using PHP. The script looks the same as the one you saw on the Raspberry. It's really just sending set value. And the door opens. Okay. Now, how can you detect and prevent these kinds of attacks? For the devices using the AES handshake, please change it. I think in recent firmware versions, most of the problems should have been solved. And we tried, but till now, we didn't find a way to circumvent the AES handshakes in general. You can detect attacks of the second kind.
If the software supports this function?
Yeah, if the software supports it, by trying to detect if another device uses your central's address. Of course, if yourself or if the software knows its own address, so if somebody else uses its own address, it's easy to detect that. HomeGear actually does that.
But sadly, you can only detect an attack, but not
you cannot prevent it. And the third thing you can do to prevent, or to detect attacks of the first kind is to do a plausibility check of the message counters. Again, it's only a detection of a possible attack, but yeah, there is no way to prevent these kinds of attacks. Thank you.
Yes, thank you very much for this presentation. We have time for a few questions, but before, if you leave the room, please take all your trash with you. And if you leave during the Q&A session, please do so quietly. Thank you. Do we have questions from the internet? Können wir das Mikrofon da hinten eingeschaltet bekommen?
Ja, wir haben eine Frage. The question is, can you also emulate a terminal control? So the terminal control itself, can it be emulated by sending commands to it?
I don't completely understand the question. We could emulate all the function of a thermal control, or is the question to emulate a thermal control in order to control a valve drive? I don't know. Actually, HomeGear does exactly that. HomeGear is emulating a thermal control device in order to in order to control a valve drive.
It's a virtual thermal control device running on HomeGear, pretending as if this device were a physical thermal control.
Yeah.
Okay, so next question from the audience on the left here.
Yeah, hi. Hello. Yeah. You basically, for the attack where you warm up your neighbor's house, you're spoofing the central control, right? Is there not a race condition? I mean, how does that work with the official, the real router, the real central unit?
what is it?
Going to be sending messages
Yeah,
at the same time?
Oh, you mean when both? What happens when both devices send messages? That's a valid question. When the real central controls the set point temperature, it will not set the set point temperature every cycle, only every few cycles. So in the cycles between that, you can set your set point temperature, and of course the valve drive will open and close constantly, but still you have the same effect.
Next question from the right.
Would it be possible to do sort of wall driving and map the kinds of devices using an SDR radio?
You mean what the hardware requirements for wall driving would be?
Is it even possible to drive alongside the road and map the kinds of devices that are used in the buildings on the left and the right?
Yeah, it is possible, but some devices only very rarely send packets. So in order to really detect all the devices used in the houses around you, you would have to wait a long time in front of each house.
And have you tried that using an SDR?
No.
Or only that special hardware?
No, we did not use a software-defined radio. It's not necessary. We simply need a Raspberry Pi costing about 40 euros and a wireless adapter costing between 50 and 100 bucks.
I'm asking because you could simply use a Realtek modified. So it's only 21 euros.
Okay, if you want to, possibly you might use one.
It would work.
It would work if it supports the frequency 868 megahertz and the shift keying mode, which is actually used. The CC 1100 chip does support several transmission modes, but I don't know exactly which mode is used because we don't need to know.
Thank you.
Okay, next question from the left.
This was exactly what I also would have asked, the frequency, because home automatic systems usually use this 800 megahertz and not 2.4 gigahertz because of the distance they can play. So it is a standard protocol is used and not a proprietary protocol. So the standard chip on the devices which everybody might buy.
Yes.
The chip is standard, but the bit cost protocol is, the protocol used is not standard.
Is the bit cost protocol documented just by reverse engineering or by the company itself?
I'm not 100% sure if it's documented, but I don't think so. We reverse engineered it.
Okay, thank you.
So next question from the left.
Hi, I was wondering about the challenge response messages with the KeyMatic exchange with the HomeMatic system. I was wondering if you could give us any more information about how that is. So for instance, the challenge that's sent, how does that get integrated into the message that's encrypted and returned?
I mean, how the payload is calculated.
Right, I mean, do you just simply concatenate the challenge? No,
we don't know exactly. Okay. We don't know exactly. We can only guess. Probably it's on the slide. Let me just see. Let me just open it. Where is it? One sec. On this slide, you can see that here are 6 bytes and here are 4 bytes, and both are within this encrypted response. So that is 10 of 16 bytes used already. So there are 6 bytes left. And probably at least 3 of these 6 bytes are one of the addresses. Maybe the 6 bytes are the sender and the destination address. We know that because address spoofing is not working. We tried that already. But we are not 100% sure if it works. And what is also not possible, by changing the default AES key, probably we have to try again. We haven't worked on that for quite a time. But probably not only your AES key is used, but a combination, maybe XORed, whatever, of your AES key and the default AES key. So you cannot just change the default AES key with a configuration adapter and then implement the challenge response. Yeah, that's still a little mystery how exactly the AES handshake works.
Okay, next question from the right.
Thanks for the talk. I wondered if you have looked into other vendors like FS20.
Yeah.
Do you expect similar, or is it different there?
FS20 is pretty stupid. It's not. It existed before HomeMatic. HomeMatic, they developed HomeMatic after FS20. FS20 is unidirectional. The devices don't really have addresses. You have, I don't know, I'm not, I think you have master addresses and group addresses and something like that, but you have not unique device addresses, and there are not a lot of addresses available. But we plan to support other systems too in home gear, like FS20, for example. HomeMatic wired, of course.
Okay, next question from the left.
Great work, guys. What about the CRC board? Did you design it by yourself, or is it somewhere to buy? And why didn't you use the busware stuff?
Yes, the main reason why we didn't use the busware stuff is we wanted to keep an exact timing. This was necessary to emulate a thermal control communicating with a valve drive device. And the CRC device we have designed on our own. It's a little bit inspired by the busware's COC device. It uses a special bottom entry connector so it can fit into a Raspberry Pi case. But in contrast to the busware's COC device, it does not communicate via UART, via a microcontroller with a CC1100 chip, but it communicates directly via SPI with a transceiver chip.
Okay, another question. Did you look into the RWE stuff, for it uses exactly the same hardware, just a slightly different protocol?
No, we haven't. No, we haven't.
Okay, next question from the right.
Did you get in touch with HomeMatic, and if so, how did they respond?
Yes. I don't know. I wrote, they are not, we wanted to post home gear on the forum HomeMatic Insight, and EQ3 was not particularly happy about that. One reason was because home gear uses the Bitcoin services XML files, and they were directly integrated into the software. We now removed that. It's not directly integrated into home gear anymore. It's still used by home gear, but now it's being downloaded on the client, at the client side. I wrote EQ3 because I don't want to have any problems with them, but until now they still haven't responded.
Okay, then let's give them again a big round of applause. Thank you very much for this talk.
Yes, in the very beginning, we started by opening a valve drive device, and inside we found an Atmel microcontroller, a wireless transceiver module hidden in the back, and of course a motor and a gear. This device is provided in a very tamper-friendly version, providing the communication interface between the microcontroller and the transceiver module as a pin header. So we sniffed the traffic on this communication interface with a logic analyzer
and soon understood how the device works, and we could soon emulate this valve drive. Actually, on this valve drive, as you can see here, probably, maybe, is already running our own firmware, which we later did not develop anymore because it was not necessary. Okay, the wireless packets. The protocol used by the HomeMatic devices is called BitCos, which stands for Bidirectional Communication Standard, and works on a frequency of 868 megahertz, as a lot of wireless home automation system. And all the BitCos packets look like this. First, you see the packet length, which does not include itself. So the length counts only the bytes after the length. Then the first byte is a message counter, which increments by 1 with each message exchange or packet exchange. Byte 1 is the control byte, which, for example, encodes the information here at bit 5 that
mode above, but without a wake me up packet. This mode is used by a thermal control device and valve drive device. One slide back, please. The receive ready mode draws about 14 milliamperes of current, so that the battery would be empty in about 1 week. So if you use a wake on radio mode, the average current draw is reduced to about 100 microamps. And the other modes reduce the current draw to about 20 microamps, plus additionally the current draw of the motor and the microcontroller, so that the batteries can last 1 year or even longer.
Okay. One important thing about the BitCos protocol is that the communication is completely unencrypted. But for some devices, like for example the KeyMatic, which locks and unlocks your door, of course you need some kind of authentication so that not anybody can unlock your door to your apartment or house. For this authentication, an AES challenge response handshake is used, meaning, for example, the central sends the command open door to the KeyMatic. This is the command. Then the KeyMatic generates a random challenge, sends this challenge back to the central. The central encrypts this challenge with the AES key known by both devices, meaning encrypts this challenge with the known shared secret, and sends this encrypted message back to the KeyMatic. The KeyMatic decrypts the communication is bidirectional. This bit, for example, means that there is a response expected to this packet. Byte 2 is the type of the message. Byte 3 to 5 the sender address, 6 to 8 the destination address, and after that the payload. There is one special destination address, 0, 3 bytes 0, which is the broadcast address.
Since most of the HomeMatic devices are battery powered, you will need some kind of power saving strategy. The first power saving strategy is called wake on radio, and it works the following. The device wakes up to receive ready mode for 2.4 milliseconds, and after that it falls asleep for 350 milliseconds repeatedly. So it can react on packages almost immediately. The second type of power saving strategy is the wake me up mode. In this mode, the device sends a wake me up packet, then is in receive ready mode for 250 milliseconds, and then falls asleep for a variable but deterministic amount of time. This mode is used by some devices for which do not have to be reachable all the time when they want to exchange information with the central. They send a wake me up packet in broadcast mode, and the central can react and initiate data transfer. The third power saving strategy is almost the same as the
default AES key when you changed it. Okay, HomeMatic in general. Our original motivation was we wanted to control valve drives directly. We were not satisfied with the built-in temperature control algorithms of the thermal control devices. And yeah, soon found out that it is not possible to control valve drives directly.
Yeah. Initially, we just wanted to write a new firmware for the valve drive device.
But that soon exacerbated into developing our own interface software to control HomeMatic devices, which we later named HomeGear.
So let's show us an example configuration. Maybe you want to start with some kind of starter kit. Maybe you want to unlock your door and switch on the light with a remote control. And if you're satisfied, maybe you want to add further components to the system. And therefore, you may want to have a control center. This may consist of a LAN configuration adapter in combination with a server running a Bitcoin service software and home automation administration software. Or you may use a standalone control center unit with a firmware doing as well the job of the Bitcoin service as further functions. Or you may use Raspberry Pi with a wireless adapter extension running HomeGear software. Then you can add devices like a smoke detector team or thermal controls to regulate your room temperature.
So, welcome everybody. This talk for today is by Satya and Mali. They have looked at the security, or maybe you could say insecurity, of home automation systems, in this case the HomeMatic. And I won't waste your time, so please give them a big round of applause, Satya and Mali.
Yes, hello. My name is Satya.
And I'm Mali.
And in the next 45 minutes, we are going to tell and show you how to sniff HomeMatic device traffic, how to emulate HomeMatic devices, and how to attack a HomeMatic system. This talk only focuses on the wireless traffic, so we are not talking about the wired components at all, and we are also not covering the numerous security issues of the LAN interface.
So, who of you does already use a home automation system? Ah.
Okay, and who of you does already use HomeMatic? Okay, a few. And who plans to install a home automation system in the future? Okay. This is the outline of our talk. First, we are talking a little bit about HomeMatic in general. Then we have to bore you with a little theory about the wireless packets of HomeMatic. And then we will demonstrate you live 3 possible different attacks. These 3 attacks cover pretty much everything, meaning after these attacks, you can, as an attacker, control pretty much all the HomeMatic devices except when you're not using the